Welcome to our experiment 1. Today's experiment topic is obtaining the frequency response of a common emitter amplifier circuit. In order to obtain the frequency response characteristic of the circuit, we will apply a sinusoidal signal to the input side. Before beginning the experiment, let's see our configuration, check our cables. Okay. This bus is for DC bias, which is 20 volts as mentioned in experiment sheet. This cable is for applying the input signal. This cable is for measuring the input signal, and this cable is for applying the input signal. As you see, this is our ground bus, and this is our output signal. We will measure that output signal with our scope. Okay. Now, as mentioned in the experiment sheet, we will apply 20 volts DC as bias for the circuit. We are turning on our DC supply, DC power supply. We are adjusting it to 20 volts. Okay, it's approximately 20 volts. Now, for this experiment, since we are beginning with 5 Hz, via this signal generator, we will adjust a 5 Hz sinusoidal signal for applying the input voltage. What was our start frequency? It was 5 Hz. In order to change the frequency, we are using that button. Frequency. Now we will press 5 and select the multiplier Hertz. Okay. 5 Hz. What was the amplitude? 10 millivolts RMS value. Amplitude button, 10 millivolts RMS. Okay. Everything seems fine. In order to activate the output, we should press the output button of the related channel, which is channel 1. Okay. What about our scope adjustment? Here's our scope. We should turn on our scope before the experiment. It will take some time to start. Okay. We see meaningless lines on the screen. If we do the proper adjustments, these lines will gain the meaning. Now we should see the full amplitude, and in order to do that, we need to adjust time due. Volt due. For blue signal also. Now, in order to see the cycle of the signal, we should maybe narrowen or widen the time due by rotating that knob. Okay, a little bit over. Okay. Yellow signal represents the channel 1, which is our input, as you remember. The blue one represents the channel 2, which is output. Okay, in order to make a fast measurement, since this scope is smart, if we press the measure button and adjust the right hand side measurement list, what do we need for this experiment in order to calculate the gain? We need peak-to-peak values of two signals, right? Okay. Then in order to adjust it into channel 1 peak-to-peak value, we are pressing the corresponding button. Source is channel 1, type is peak-to-peak, we don't need to change it. Okay, measure button again. Now for channel 2, corresponding button, source is channel 2. Okay, we don't need to change the type. Measure again. Now we see two peak-to-peak values. Okay, for 5 Hz, the input value is very close to the output amplitude value. That means our gain will be approximately 1. Now, in order to see the effect of the frequency on the output, we just increase the frequency and see what happens on the output side. In order to increase the frequency, we are just pushing again that frequency button. Now we are increasing it. Oh, did you see that? The gain has been boosted. The gain is so much higher in this case. What is the frequency? 15 Hz. What is the gain? 120 over 38, maybe. What about the higher frequencies? Did you see that? The gain is so much bigger. 464 millivolts versus 38 millivolts. Don't forget that input amplitude will not that much change because it's a constant, approximately constant. Now we are increasing our frequency. Now, do you understand? For higher frequencies, we get higher gain. But what about much higher frequencies? Now, for much higher frequencies, maybe for 15 kilohertz, maybe for 150 kilohertz. Look at the gain. It's starting to decrease. For higher frequency, it significantly decreases. Very low gain. Now, where did we get the maximum gain? Maximum output voltage. For which frequency did we get it? Okay, approximately 700 millivolts. Okay, will we get higher value? No. Okay, it seems we are not getting the higher values rather than 700. We are obtaining the maximum output voltage at these frequencies, right? Now, at which frequency it is starting to decrease? We need to find it. At which frequency? Okay, now we are increasing our input frequency. 70 kilohertz. Yes. It starts to decrease at 30 or 50 kilohertz. At first step, we should find the maximum gain in decibels, and at the second step, we should find the frequencies corresponds to the -3 decibels below the maximum gain. We will find two frequencies at this case. One of them will be our higher cutoff frequency and one of them will be our lower cutoff frequency. For this experiment, as you can see on the table, these two frequencies are 150 Hertz and 150 kilohertz respectively. The first one is our lower cutoff frequency and the second one is our higher cutoff frequency. And between these frequencies, we call that region as our bandwidth. While you are plotting your body, don't forget this x-axis is in logarithmic scale and this x-axis represents the frequency and this y-axis represents the gain in decibels. Now, for this experiment, lower and higher cutoff frequencies we have. And here is our maximum gain, and these 2 points are -3 decibels below the maximum gain. -3 decibels below the maximum gain. That's all for today. Thanks for watching our video and see you next week. Take care.